Today let's study why integral 1 over x dx is equal to ln x plus c. First, let us intuitive the whole problem. First, we write out the function 1 over x. Okay, and then it's 1 over x. And we integral it. We integral it so we can got, and we draw a picture, and then we draw a graph. This is the antiderivative of 1 over x. And we know it's like this. Infinity of them. And these functions are called ln x plus c. Okay, and of course we all know each function generally has two intersections with x-axis and y-axis. So now, and another thing, each point on x-axis can map the slope that when the antiderivative choose the point that we choose before, that is what we know now, right? Okay, so and we know, and because we are finding the function ln x. So that means now our job is to find out the intersection, to find out a defined intersection. But we can't because there are no intersection of a logarithmic function with y-axis. So, and there has another solution is to find out the intersection of ln x function and the x-axis. And we all know that the x value of the intersection is 1. So we can write out. So we can change. So of course we have an idea is we can give the antiderivative domain is from 1 to x. Right? And let's see how do you change. Of course we know here is the area, right? First this is 1, right? We know this one is 1. Okay. Well, this is 1. This one are 1. And x choices like this. And of course, when x moves to the right, it's like this. So the area is like this, right? Changing on this. And if x moves left, the area is changing like this, right? So so what about in the antiderivative function? We can get the ln x function. We can get. Okay, I just said this function. Okay, this function is ln function. You see, this is 1. This is 101, right? Okay. Okay, this is our inner function, okay? This. Okay, so now let's move from the point 1. Okay, point 1. Point 1, okay, we x move right. So what about y value changing? This, right? Okay? And when x move left, like this. So the y changing are going to be negative. And when x get right, y changing are going to be positive, right? Of course, you see, because in here, x moved to the right, the area are positive, right? But when x get left, see, the area are negative. So now, that means now we have solved our intuitive problem. But this one part of this problem. Now we need to prove this. Now we need to prove this function, this antiderivative problem based on algebra. Okay, first integral 1 over x dx now, and we can substitute. First we set x is equal to e to the t. So that means we substitute the e to the t to x. And so now of course we know dx, right? Dx is the increment of x, right? So we know if that's increment of x, so we can derivative e to the t then times dx, then times dt. Because this function is you plug a number in t, right? Okay, so that's times dt. And e to the t, and you derivative it, of course, and when you derivative e to the t, of course that's e to the t. So dx is equal to e to the t times dt. Okay, so now we just substitute e to the t in x and substitute e to the t times dt in dx. Okay, so now is equal to integral 1 over e to the t, and then times what? Times e to the t dt. Right, okay. That is very easy because e to the t that cancelled out, so that's integral 1 dt. Right? Okay, so that's easy. That's t plus c. Right? Okay. T plus c, so that t plus c. Okay, t plus c. And t plus c, but don't forget, we need to substitute it back to x. Or substitute it back to x. Okay. So now of course we know, because x is equal to e to the t, so we know, of course, it's opposite, right? T is equal to ln x. So t is equal to ln x. Okay, so now we just substitute ln x with t. So that's equal to ln x plus c. Okay. And the last part is we are talking about the domains problem. First, let me complete the 1 over x function. Okay. Right. Okay. So now it's like this. The function is like this. Okay. And now we know the domain of 1 over x function is and we know x is the member of positive, x is a member of real number, right? And x is not equal to 0. And we know L and x plus c, this function are a logarithmic function. And we know the domain of a logarithmic function is x is the member of positive real number. It's the member of positive real number. Okay. And so their range are not the same. Right? These two functions domain are different. Are not the same, they're different. So now let's think. We can change L in x plus c, this function, to L in absolute value x plus c. So now what's the picture look like? So now the picture changes like this. Okay, now the picture changes like this. So the function is like this. Right? L in absolute value of x plus c. So now what its domain change to x. X is the member of what? Member of real number, right? And x is not equal to 0. So now these two functions domain are the same, right? Okay. And now let's go back to the first part that we are talking about. And if you think you want to know what we are actually talking about, it is why we give a domain is 1 to x. First we choose a x value, maybe like here, maybe like this point, and then we plug in this function and we plug in here so we can get the area, the region, this right here. And I use 1 to plug in this so I can get another region like this. And so I can get their difference are like this region, right? And actually this is in the L and X function. Is this y value? This is this unique y value, right? And the same, when x choose each value, we have each, it's the same, right? We have each unique y value. Okay, so when we connect these points together, so we can get a perfect L and X function. So let's draw it out. This is an L and X function, and this is 1. Right, this is L and X function. So we prove this whole problem.